Welcome to Cadence Design Systems Omnis Tutorial Tuesday, where we show you how to use our fully integrated environment Omnis in short videos of a few minutes. In this video, I'll cover the main features linked to Turbomachinery non-axisymmetric end walls meshing. Omnis AutoGrid allows meshing non-axisymmetric end walls in two steps. First, an axisymmetric mesh is generated. Second, the axisymmetric mesh is adapted to the specified non-axisymmetric end walls. We can consider the example of an axial turbine stator row with axisymmetric hub and shroud curves, which has already been linked and set up in the geometry context. The procedure up to here is simple and is covered in a dedicated video for automatic turbomachinery structured meshing. Let's take the example of defining a non-axisymmetric hub for the current configuration. We start by importing the CAD file, here in parasolid format, containing the concerned CAD surface of this exotic end wall. The geometry can cover any azimuthal theta range and doesn't necessarily need to be aligned with the linked plate. Next, with the Surfaces and Curves graphical selection mode activated, select the CAD surfaces and click the green hub icon next to row 1 in the family tree to replace the original hub surface by the non-axisymmetric configuration. The icon turns blue and the linked geometry is shown in the 3D turbo view. The next step is to select the turbo configuration, click on the Create Mesh Setup button located on the top of the family tree and switch to the mesh context. The non-axisymmetric hub and non-axisymmetric shroud options under row 1 3D tab are used to enable or disable the mesh adaptation on the specified non-axisymmetric surfaces. The Geometry Repetition option allows to repeat the surfaces by rotation until the blade domain is covered. This is needed to ensure that the non-axisymmetric passage covers all the hub or shroud blade-to-blade domain of the axisymmetric mesh. In this case, 2 repetitions are enough. The Repair Non-Projected Points option allows to correct poorly projected points between axis and non-axisymmetric entities. We can keep this option activated. Identical settings are also available for a non-axisymmetric shroud. Next, we launch the Row Wizard for this row and generate the 3D mesh. Once the task is completed, the final mesh is shown in the 3D view. Use the turbo features of the right-click menu of the mesh setup to hide the rotor-stator interfaces, hide the shroud, and show the repetition. By setting the 3D view to full screen, we can access the 3D mesh. Note that the points from hub to shroud got adapted in order to capture all the details of the non-axisymmetric hub. Finally, click on the Show Mesh Quality button in the pie and select the AutoGrid tab. The table shows a structure mesh with great quality metrics with approximately 1.1 million points generated in 47 seconds on 2 processors. Thank you for watching. If you liked this video, be sure to click the thumbs up button to subscribe to our channel for more upcoming content like this. If you have any questions or suggestions for future videos, please drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a great Tuesday.